Hello and welcome to another video where we're gonna learn stuff about Solana. Is this gonna be a tutorial? Who knows? It's gonna be one of those videos where I just go on Solana Stack Exchange and attempt to learn something. I don't know what yet, but I guarantee that we will learn something, because otherwise there's no point in making this video. But yeah, at this point, at the beginning of the video, I have no idea what we're gonna learn. I have no idea what we're gonna look at. The only thing I know is we're gonna go to Solana Stack Exchange, your #1 place for asking Solana questions. Hold on, this is so bright. Does Stack Exchange have a dark mode? No dark mode, fine. What are we gonna have a look at? What's here? Top questions. Problem with getting seed for Market ID PDA. So first of all, the create with seed is not a PDA, it's just creating an account through the system program in some way that the system program derives stuff. Not a PDA. Create account with seed, not the same thing as a PDA, because we can't sign for this. One could say a system program PDA, but it's not a PDA. My definition for a PDA is that programs can sign for it. And that's just not the case with those. The reason some people use the create with seeds for the market ID for Pumpfun radium migration or whatever is because they don't need to create a private key first that they then throw away anyway. So the create with seed just makes it easier, saves the signature, and therefore saves on transaction base fees. So that's not a PDA, and therefore you cannot derive it. That would be my answer for this one. Yeah, well, there would be a lot of money in actually knowing how those market IDs are created. But as far as I can tell, you can't derive them. They're not derived. They're just created by however the Pumpfun migration program or whatever script does it. I guess that's their secret. I mean, they will know, but that's not something that the community knows or I would know. They keep that secret. I mean, we can have a look at that. Hold on. For example, to get this market ID, let's check. Now, it would be nice to be able to find the first transaction of all of the transactions. The Explorer does not support that. How would I do that? Use another Explorer. Check transfers. No, transfers. Here you go. Even though I often... Wait, hold on. Here we go. Even though I don't like the Explorer for showing so many ads, their indexing is still pretty good. So this is the first Explorer that I can actually find that transaction I'm looking for, which is the one that funded the account. And that was 27 days ago. And what we see here is this create account with seeds that they were talking about. This create with seeds. But this is a system program thing, and it's not actually creating a PDA. Yes, it's creating this address, this market ID, and we can even check the seeds that it's using. That's the seed that it uses, but whoever creates that transaction is defining that. They put that into that transaction. Pumpfun radium migration address creates that. And either that's just random, or that's a hash of something, or that's based on the actual, I don't know, mint or market or whatever it is, but we can't tell. Only the people who create that transaction know, because they enter the seed. It looks somewhat like a hash. Wait, how big is that? 32. I mean, that is somewhat of a computer science number, isn't it? 32 characters, and it looks like which encoding? Kinda looks like base 58-ish. Doesn't have zeros, it doesn't have... So yeah, potentially it's a base 58 encoded something. Actually, let's base 58 decode this. If we decode this, well, I mean, we get bytes, 24 bytes, but they look kind of random as well. That's not even a mint. What is the mint? That's probably the mint. Let me get the Solana Web 3.js pub key from there. So those are the bytes from the mint. No overlap with that at all. So I still think that this is random. I think that's a random 24 bytes and it's doing a base 58 encoding on it. Or it just comes up with random letters. Although this does look like base 58, but I'm not sure. So the short answer is you can't. You don't know that seed. You cannot predict this. And it's not a PDA. It is just a system program create account with seed, so that this guy can sign for creating that account. And the reason they do it is such they don't need to provide another private key that they need to sign for creating all of those accounts. And my best guess is those seeds are all random. 24 bytes gives you enough randomness to not ever have duplicates. Yeah, I guess that's just random. And I can't tell. And maybe they have a secret. And I don't think so. That's the answer to this question, which I'm not gonna write here. There we go, now I said it anyway. But that wasn't particularly interesting because who's interested in Pumpfun? So let's not look at more Pumpfun questions. Mismatch types, is that interesting? This looks like a not enough sol issue and it's already answered. Well, that sounds fun. Yeah, we could do more on transfer hooks. I said that I would do more videos on a transfer hook. Should we build a custom transfer hook? The problem with this is you can't do it directly because for that you would need to set a delegate, because in the hook all of the permissions are revoked. So you can't transfer, can't steal the user's sol or anything in the hook. Well, security. Okay, but so not today. What's hot? Mint issue. It kind of sounds like that account doesn't exist. It kind of sounds like you're doing it in several transactions and then sometimes one transaction doesn't have the correct state yet. No, you're doing it all in one transaction. No, there are two things. So instructions create and the instructions mint. So let's assume that this didn't go through yet, wasn't confirmed, or your RPC just doesn't have that state yet in the commitment that you're simulating for. And then basically the mint doesn't exist yet because you didn't even create the account yet. And you're already trying to create a token account. So what I would expect to happen is that this one will already fail with the mint doesn't exist or something like that. And we get the simulation failed, transaction simulation failed, custom program error 0x2. I don't know what this one is. We invoke the associated token program, which invokes the token program. And that one says invalid mint. Forget account data size. So the associated token program first checks on what size a token account needs to have, and that depends on the extension. So it puts in the mint, but then the token program says, hey, that mint doesn't exist. So it errors with invalid mint. Yeah, so that's a simulation error. I'll quickly write it down. Fine. Some ideas how to fix this. So it's a timing issue. The first isn't ready yet when you send the second one. So either you wait between them, either have a delay or wait for it to be confirmed or even finalized. Or you change the pre-flight commitment to processed, basically telling the RPC simulate against the processed state, not the confirmed state. And there is like a second between that. So it's more likely to succeed. Or you don't simulate at all and you say skip pre-flight, just send it. Most likely that will work because the first transaction will land on RPC before the second one. So it will just send both of them to the validators and they will process it sequentially and that will be fine. It's mainly a simulation thing because you're not waiting long enough for having the up-to-date state. Those are my 3 fixes. There are other fixes as well, but that's the things that I would recommend. Actually, I don't recommend this one, or only if you then manually confirm it. Hope that helps. Send. There we go. I'm so helpful. But yeah, that was easy. What else? I want to do something fun. Let's see. There's one bountied one. Maybe this one is interesting. Squats. Reached end of buffer unexpectedly. When creating a larger transaction in squats, the transaction will simulate fine, possibly even execute fine, but you can't see it in Explorer. And we can even send the transaction, so we know it's valid. What's up? Oh, that's an interesting question. What's up with that? Here's an example. If we look at the inspector, it will error. But if we simulate it like this, so that's the transaction. There we go. So it simulates that just fine. Build budget, this program, and then it errors though. System program errors with 0x0. Account already exists. It even logs that. The system program has a log for allocate address already in use. The system program does logging. That's new to me, but okay. Yeah, so anyway, we could simulate that. Let's do the same thing from the inspector. Must be base 64. Oh, that's why it had this. Okay, that's how the Explorer will understand it. There you go. Whew! Yeah, okay. So this seems to be an Explorer kind of problem then. Or is the encoding here questionable? Wait. Maybe it's I'm putting in just a message and not an actual transaction kind of a thing. Because what do we do here? We create a versioned message from the, we create a versioned message. We serialize that from the buffer. So this is just a message, not the entire transaction. If we wanted the entire transaction, I think that's your error. So cool, I can replicate your error, no problem. Well, actually, let's do it again. Look at the console. Trying to access beyond buffer length. Yeah, because it expects more to be read because the buffer is malformatted, because you're putting in only the message and not the entire transaction. All we gotta do is serialize the version transaction. So this guy, whether or not you have a different block hash now, it doesn't really matter. Transaction serialize, and then we make a buffer from that to string that in base 64, and we log this. This way we will also get the signatures. Look, so compare, that's what you had and that's what I'm having. It's the same thing. If you would decode that, it's the same, just how base 64 works. It doesn't look the same, but it is a lot of the same bytes in the end, just that we have this list of signatures in the beginning, and here it says how many signatures there are and stuff. And when it interprets this as how many signatures there are, then it's just too many, something like that. So basically, this is what we want to put in Explorer, and hopefully this it will understand. No, it does not. Damn it. I thought it would be so easy. Okay, fine. It's not that easy then. I'm gonna figure this out anyway. It looks like it has one empty signature here. Let's print the entire transaction. The header also just says number of required signatures is 1, so that's fine. So maybe what you're gonna learn now is how I go about debugging stuff like this. And maybe I find an error and maybe I don't, who knows. My next approach, if this is not working, do I have another simulator? It might just be that there's a bug in the Explorer, but just for myself, write all of this as base 64. ID serialize, we log this one more time. Would that be the same thing still? This looks like the exact same thing. So I have 1001 bytes. Good that I used not 1000. I was like, I could just do 1000. No, it's not enough. It's 1001 bytes. And yes, it can deserialize that. No issue. Same as above here. So that's not the problem. It seems to be an Explorer thing, an Explorer bug actually. Great, now we're gonna debug the Explorer. All right, how would I do this? Well, by stripping stuff. So my goal is now to remove stuff from the version transaction and then see if it's still a problem for the Explorer. So the problem is that this is all just read-only, I think. I don't know how to work with the old Web3.js. With the Web3.js, it's now just called the Web3.js. I know how it's done with the new one, but I don't know how it's done with that one because it's complicated for versioned messages. Is there a decompile? Because I also just have the compiled. I want to decompile. I know how it's done in the new Web3.js. There's an example for it. Hey, you know what's also cool? Now that the one thing is called the Solana kit and the other thing is the Web3.js, I can import them both. pnpm I Solana kit. Because I know how it's done with a kit. Deserialized transaction goes through the entire process of, there we have the base 64 encoded transaction. That's step 1 with the transaction decoder. Transaction decoder, decode buffer, for instance. Oh wait, this is still base 58. And this is what I will put in here. Except this is a string. Hold on. Let's put that here. There you go. So that's the transaction. We have the signatures. We don't have a signature for this one. And this is the message bytes. Then the next step is to get the compiled transaction message. We get a compiled transaction message decoder, decode the kit transaction message bytes. And then we get the decompiled transaction message. It's just a decompiled transaction message. Because we don't have lookup tables, I don't need to query the lookup tables. Just put in the compiled transaction message. Because it does it in steps, you know. First, we just have the base 64 string, then we get the string to actual bytes. From the actual bytes, we get this transaction object, but that still has, you know, the transaction formatted the same way that it's on the wire, kind of. So in a compiled way, that's the entire transaction. So that's just the list of bytes. Here we get the compiled transaction message. So we have it already in the format where, you know, we can access the header, the instructions, and so on, but still in a compiled way, so with like the numbers of the accounts and everything. And then a decompiled transaction message, this guy, there we actually have the instructions as actual objects, how we used to them. So that's the whole way in the one direction. And here we can actually, you know, work with this decompiled message. Oh damn it, but this is also still a read-only. But doesn't matter, because here I can just create myself my own message then. To build myself the same message as above, I'm just gonna call this D message because it's shorter. So from D message, I use the version. So same version. I use the same fee payer. Needs the address, okay. Lifetime, can also get that from the message, same lifetime constraint. And here I can, if I set it, I have to set either this or that, and it will only take either this or that. That's the problem with types, damn it. There you go. It's a bit ugly that I need to force it in like this, but I know that it has a block hash lifetime, so I'm just gonna take it like that. And then I append the transactions, which I also have in my decompiled message. Sorry, the instructions, they're also in here. All of those instructions go back in here, and then I have the same message as before. And then I should be able to also, how do I get from this to an actual transaction now? Because this is just a message. Or actually, should we first simulate this? Simulate transaction takes base 58 encoded wire transaction, a base 64 encoded wire transaction. It needs a wire transaction. Okay, fine. Here we need to compile it in the other way again. Hold on. So here we need the opposite of this thing. Get compiled transaction encoder. Encode the compiled transaction message. So how do we get from the message to a compiled message again? Compiled transaction message. Compiled transaction has message bytes and signatures. Perfect. So that's what I can put in here directly already. There we go. Then we encode that, have a wire transaction, and that's still not what we need here. Hold on, what's this then? Oh, here we encoded it to an array. Hold on, that's not what we want yet. Get wire transaction from a transaction. Yeah, there we go. Use this, not this. It needs to know that it's base 64. Then this will work, hopefully. And we should get a simulation like this. Let's log that simulation. Let's see if we get all the way here. Oh, hold on. We didn't send it. That happens sometimes. I forget to call send because that's what the kit needs to actually do it and not just build that. Looks good. See, we get the same error. So it seems to have compiled the exact same transaction. That's the wire transaction. We can also, hold on, let's console log this wire transaction. I'm guessing that's this. And that looks very similar to what we had before, you know, here. All of that thing. Yeah, seems to be the exact same thing, yeah. Nice. So we did manage to do the exact same thing with a kit, but the inspector will still fail on us if we put that in. Yeah, thought so. So we didn't gain anything yet in this entire half hour of working with this. What can we do? Instead of, you know, adding all of our instructions, How about we're just adding instruction 0? Let's just do that. Rip it apart. Wow. We just have the 1 and even that fails because compute budget exceeded. But if we have a look at this, did they change it now that you need to specify compute? Otherwise you get 0. But did you see? This I can put in here without the Explorer dying on me. And I have a set compute unit price. And if I simulate it here, computational budget exceeded. Because this one instruction already needs 250 compute and I requested nothing. And maybe if I request nothing, then it says it's 0. Is that already the case? I read something in a SIMD once. What if I only have the second one? Hold on. If I don't do this one, but this one, then, oh, there is only the second one. Then I get this. Okay, let's see if I can put this in inspector. No. So it seems to be specifically with this instruction that it fails. There seems to be something weird in this instruction that the deserialization fails. Everything else works just fine. We are just putting in this one instruction here. Is there a third one? Here, this third one would work again. And would the inspector accept it? Also this the inspector would accept. So there just seems to be an issue with this instruction, which in my program and here in the script, it work, like I can simulate it, it doesn't go through, like it will have an error because that specific transaction, that account already exists. But the weird thing is, why, if I serialize that, the wire transaction, does the inspector die if I do this? There seems to be a bug in the inspector. Never looked at this. Source code of the Explorer. I should probably just clone the entire thing. One would think in transaction, inspector. Let's try if we can run this. There is a next def. Let's try run def. Compiled. Give me the Explorer. Yeah, we have the Explorer locally. I like this. Go to inspector. Oh, this is all a bit laggy and like very slow. Inspector, please. Why not going there if I click? Oh, because it's compiling the transaction. Inspector. Sure. It just takes a while then. Because this is a big project, yeah? And it's just compiling when I request. Compiled. Oh, it compiled supply. I want the inspector. Yeah, there's the inspector. So, if I put in the thing that we had here into here, it will work. Interesting. I mean, yes, very interesting. So locally I cannot replicate that. Oh, that's annoying. And with the entire thing, even that works. With 1001 bytes, here the entire transaction could be serialized. That's annoying. So it's not, so it's like it is an issue with the current, maybe this has other limits set or something, because here that just works. Okay, how about I build and then start? Good, done. Then we start, there we go, go to the inspector, there we go, paste this thing, and that it just takes it. This version of the Explorer, although not even sure if that's the newest one, that was updated yesterday, hosted by Solana Foundation. I guess that's correct. I guess that's the one. Like, there is active development on it, so I guess that's the one that we're actually using as well. And I can't replicate the error. That's annoying. I mean, it's kind of good because it means there is no error in a way, but also, why is this failing then? Oh, that's probably the most annoying outcome that one could look for, because I'm like, I can't even replicate the error locally, and then I can't really fix it. So I don't have a good answer for you, and that's a bit annoying, storytelling wise. So in other words, I don't know. This is weird. But I cannot describe why the Explorer can't simulate this, because I can't replicate it. The Explorer can't simulate this. Well, it can't simulate it because it can't parse it. It can't parse it because I don't know, weird bug that I can't explain. So, I don't know. We didn't learn much. We answered 3 Stack Exchange questions, but they're also not real satisfying answers, so... This video is basically just how Solandy solves problems, or goes about solving problems, without actually managing to. Yeah, I mean, you gotta try stuff to learn, and this time we didn't find much. We learned that there's a weird bug in the Explorer that I can't track down in 3 hours of trying to. But it's always good to have a look at the Stack Exchange and just see what's going on there, playing around with stuff a little bit just so we practice. We saw differences between the Web3.js and the kit. We saw how we can run the Explorer locally. I need a break now. I will see you potentially in a future video. Till then, bye bye. I'm not even gonna tell you to like this because I don't even like this myself. Bit of a sad story that we couldn't fix that last. Hey, but we answered 2 other questions. Sometimes the answer really is just, well, there is no answer. Like with that market ID, how can we derive that? We can't. You can't. Not how this works. How can we fix that in Explorer? I don't know. Update to the newest version or run locally. Something like that. And I guess time will fix that. Yeah, okay, bye. Don't have more to say.